Hello and welcome to our Logistics Simulator series. My name is Castillo from CPE107 Lab D1 Group 4, and today we're going to create and analyze the basic logic gates, but mainly we're going to focus on XOR and XNOR. And so first I will demonstrate how to create an IC. But in this case, I already created an XOR gates, XOR IC, which is IC7486 and the IC74266 for the XNOR gate. So we're just going to create the NAND gates, which is the 7400 IC. So we will be using the NAND gate. So first we will need to create a circuiting. So we're just going to name it IC7400 parentheses NAND. There. And we will use this workspace. And we first need our NAND gate facing south. And looking at the schematic diagram here, it is all facing on the same way. So we just need to copy paste this 4 times. There. So we will need our input pins facing east. Copy paste this twice. And we need a pin facing east as well, output pin. And then we're going to choose the font size at 26, and we need to make it bold. And we align this one better. We copy paste it again for the second gate here. Okay, and then we copy paste this 6 to the other side, and we just flip the inputs and the label elevation. There. And then we would want to add a label on each pins. So this one is 2, 3, plus 3. There. 4, 5, should be on west, 6, and let's compress it. There. And the 7th pin in every IC will always be the ground. So just add a symbol for ground and the input output on the base. Add the label here and just make it 26 and bold, and then rename it 7, and of course arrange it so be pleasant to our eyes. And we do the same on the other side. There, we make it 8. Okay, that's it. And 8. This one's 9, 10, 11, 12, 13, and the 14th pin will always be the power gate here. So we just add the power gate and add the label here, and bold, font size 26, 14, then and we will add a text here that indicates the IC and the type of gates that we are using. So IC 7400, and I'm just gonna copy paste this one, this label right here for our NAND. And rename this one as NAND gates. Of course, don't forget to connect the pins on the input side, which is the bottom part, the flat part, and the output at the ball part, where it looks like a ball. Okay. So it's a bit cramped up, so we're going to adjust that. Set to then connect this one here. Okay, so that's all set. Let's just put this one. And set it to what? What happened? Just gonna hit it again. Okay, so now we fix the other side as well. Pin 13, so it's at pin 12. And we just sit here. Then this one is pin 10. And this one is at pin 9. And this will be at pin 8. Okay, so now we're going to look at the circuit, what it's like when it will be used on the different diagram. So we click this box right here, and as you can see, this will be the image of our IC 7400. So we would like to add, well, I would like to add a text right here that states NAND, so that every time I'm using it, I will always remember that this is a NAND gate IC. So then we click at main, and now if we can now click the IC NAND here, click it on main. So as you can see, there's no label on the middle part of the circuit, so you can just type here on the IC shared label 7400, and of course let's make it bolder so it's better to see. And that's how you create an IC 7400. And now we're going to analyze our XOR gates and XNOR gates. So looking at our IC 7486 here, so The symbol for XOR are this cone shape with an arcing line above. So the rules in XOR gates are if both of the inputs are the same, then the output will always be 0. So as you can see on the right side, we have pin 13 and pin 12, both are 1. So the output at pin 11 is 0. Same thing applies for pin 10 and 9, both are 0. And so the output at pin 8 is 0. And the other rule is that if both of the inputs are different, then the output will always be true. So as you can see in pin 1 and pin 2, we have 1 and 0. And the output at pin 3 is 1. Then at pin 4 and pin 5, we have 0 and 1. Then the output is 1 on pin 6. So that is for our XOR gates using the IC7486. Now we look at our XNOR gates. So as you can see, the difference here is that there's a bubble on the tip of the cone. So there's a circle right there. And the structure for IC74266 is different. So as you can see, in our XOR gates, all gates are pointing downwards. While in the XNOR gates are pointing in the middle. So as you can see, we have output pins at 3, 4, and 11 and 10. And so the rules in XNOR gates are if both of the inputs are the same, then the output will always be 1. So as you can see on the right side, and pin 13 and pin 12, both inputs are 0, then the output at pin 11 is 1. While in pin 9 and pin 8, both inputs are 1, then the output at pin 10 is also 1. And the other rule in XNOR gates is that if both of the inputs are different, then the output will always be 0 or false. So as you can see at pin 1 and pin 2, they are different. We have 0 and 1. Then the output at pin 3 is 0. And looking at pin 5 and pin 6, the input is 1 and 0. And so the output at pin 4 is 0. So that is for our XNOR gates using the IC74266 circuit IC. So that's all for our Logisim Circuit Simulator series. My name is Carlo Castillo from CPE107 Lab, Section B1, Group 4, and thank you for watching.